Welcome back, ladies and gentlemen. Yeah, like and subscribe, punch on the notification button, and also comment. It's the only way I can survive through you. So what's going to happen, we'll go ahead. We're still focusing on what we call half-life. Like what I said, half-life, this is just time taken of which concentration decrease by half to its initial value. So what's going to happen is this. This is, this is the half-life formula. This is the half-life formula. This is the half-life formula for zero order of the reaction. So what's going to happen hence if you have this kind of formula? Hence, this half-life being a time taken of which the concentration of the reactant decreases by half to its origin or to its initial value. Hence, that changes from the concentration depend on time to concentration depend on initial, which is equal to constant by time plus initial concentration of the reactant. So what's going to happen, talking of half-life, we're not to say it's decreasing by half. What's going to happen is if you try to do this, I'm going to try to arrange it or rearrange it, whereby same applies with negative K constant time plus initial concentration is equal to the half of initial concentration. What's going to happen once you try to do this? We correct the right terms. We say negative constant time is equal to initial concentration divided by 2 minus initial concentration over 1. So once we do that, what's going to happen? We'll go ahead and say divided by 2, 2 to 1. 1 times initial concentration, I'm going to have initial concentration. 1 into 2, 2. 2 times the initial concentration is 2, the initial concentration. We maintain the same thing, we say negative KT divided by 2. Initial concentration minus 2 initial concentration are going to have the initial concentration of the reactant. So what's going to happen once we try to do that? By the way, can we try to replicate, or let me say, can we try to affect the negative charge? Yes, shall we? The negative are going to have constant time is equal to initial concentration over 2 divided by K. Note that we're looking for time taken, so whereby decrease by half is equal to, we try to rearrange the initial concentration divided by 2. Same applies with 1 over K. What I've done here is the same applies the initial concentration divided by 2 divided by K. So this and this one are the same. So therefore, half-life of zero order of the reaction is equal to initial concentration divided by 2. We know to say 1 times initial concentration, that is initial concentration of the first reactant, 2 times constant, that is constant. So this is the half-life formula of the zero order of the reaction. Okay. Go ahead, the first order of the reaction, I'll talk about the half-life. So how are we going to deliver the formula of first order of the reaction? Note that these are some of the first important questions that you're supposed to note, or let me say important equation when it comes to delivering the formula, because whether like it or not, you're going to face them in an exam. So what's going to happen? We want to say time taken. This is, let me say half-life. This is the time taken of which the concentration of the reactant decreased by the half, or decreased by half of its initial value. So what's going to happen? That changes from the concentration each point of time to the concentration which is decreasing to its initial value, KT plus initial concentration. We know to say this is the in, which is natural log, divided by 2, based on it decreasing by half. So just to rearrange like what we've been doing, we're going to have negative KT plus the in of initial concentration is equal to the in of initial concentration of the reactant. Collecting the light terms are going to have neg KT is equal to the in of initial concentration of the first reactant minus the in of initial concentration. Now, should I take you a little bit? Not if we have the logs, I'll take you a little bit in mathematics. If we have the log of A base A, the log of B base A, minus the log of A or the log of C base A, that means to say, to really like this one, same applies with the log of A base B over C. So this same applies with the log of A or the log of B base A minus the log of C base A. So this same applies with this, or this same applies with this. So the same statement that we have used here, can we try to apply it here? That means to say, we're going to have neg KT is equal to, we'll try to remove outside here, which means we're going to remain with the in of initial concentration of the first reactant divided by 2, divided by, we know to say negative tan into division, the concentration or initial concentration of the first reactant. Note that the one that is on top, initial concentration of the first reactant depending on the time, based on the perspective that half-life is being